Very good afternoon and warm welcome, Informed NCSU chapter students. I hope you remember me. I was the past year president and now I'm working as a past president for this year. Thanks for organizing this session today. And it gives me immense pleasure to welcome Dr. Ryan from Nebraska Lincoln University, especially from the College of Business side. So we were following it up, to get her schedule, and she's very busy, and she's teaching as well as her researches in top class notch. We were not able to get it in the spring semester. Fortunately, we were happy to welcome her today in this session. So she did her undergrad in mathematics and master's and PhD in industrial systems engineering from Northwestern University. Her research is primarily in the areas of inventory optimization, supply chain coordination, supply management, and then the basic facets in coordinations, games, applications on different contracts. So it's a pretty interesting topic where she conducts research, and whatever research she publishes, it will be only in the top journals like POMS and MSOM, including, let's say, management science, whatnot. So we are very happy to have with us Dr. Ryan, because she is from industrial engineering background. And today's topic is she is going to enlighten us how from industrial engineering, how people can transform themselves to supply chain and operations management. She's going to touch upon the basic requirements if someone wants to go to academia in the first half of the session. In the second half of the session, probably she's going to enlighten some of our master students who is doing their industrial and systems engineering and operations research. If they go to industry, what kind of projects and jobs they can take in forward. I welcome Dr. Ryan. Before we start the session with her, maybe I'll request Ajit to take a group photograph. If all the participants, open their camera, that would be helpful. We'll take a group snap. Oh, some of you are sitting inside the department, so this face mask is mandatory. I understand that. Okay, Ajit, on your call.
Yeah, I'll take the picture in 3, 2, 1, smile. Perfect. Thank you.
Thanks, Dr. Ryan. It's all yours.
All right. So can everybody hear me?
Yeah. Yes.
Okay. So I'm just going to share my screen. Yeah, so let's start a little bit with, first of all, I'm very happy to be here. Thank you very much for inviting me. And I'll start by just telling you a little bit about what I'm going to talk about. This is the abstract that I had sent. And so, people with advanced degrees in industrial and systems engineering are somewhat unique in the sense that they have this mixture of quantitative and analytical skills, but also typically they have some kind of domain or application area expertise. And that's a powerful combination, right? And it can really give you a lot of flexibility in terms of your career path. So what you do with your degree can be highly varied. And so what I'm going to talk about in the first part of the talk is some options available to PhD students who are interested in pursuing an academic position. And I think maybe a little bit about what I want to do is try to encourage more people to consider an academic position and really think about maybe if that kind of career path is right for you. So this would be not just for your PhD students, also for the master students who are thinking about, should I get a PhD or not? That includes the question of, it may be an academic career if I do get a PhD. Is that something that would work for me? And so I'll talk a little bit about that, and I'll outline the differences between academic career paths in engineering and business schools. While there's a lot of positions right now in engineering schools, there's even more in business schools, and you can really diversify your options and open up more opportunities if you do consider both business schools and engineering schools. And there's value from our side, the people doing the hiring, to hiring somebody with an engineering background for these positions in business schools, and I'll talk about that. And so that's the first part. And then the second part of the talk, I will talk a little bit about, the transition that engineers working in industry need to make when they move into more management-oriented positions. So why this topic? Why is this a good topic to be talking about right now? You know, when I was asked to speak and I decided, you know, this is a good semester for me to do it, I was thinking about, well, what do I have that I could talk about that would be somewhat unique? And I have sort of a unique background in that I've been in both environments, engineering and business. And I thought, well, maybe I could share some of that experience. But also beyond that, if you look at the job market, you're seeing universities are seeing increased interest in both analytics and supply chain management. And what you've seen, and I'll show you some graphs, is rapid introduction of new courses in these areas and new programs in these areas at both the undergraduate and the graduate level. And at the graduate level, it's mostly at the master's level. The growth in analytics started a number of years ago. It's been very popular in the past 5 years or so. The growth in supply chain management programs is more recent. And of course, it's partially driven by the attention that supply chain management has received during the pandemic. And so you see a high demand among students for these programs. So when you start these new programs, you get a lot of students right away. There's a lot of interest. And those students are really responding to the needs and the demands of the job market, right? And so they're seeing where employers are looking to hire and they're reacting to that. And so when you've got all of these new programs, all of these new courses being offered, that means that we in academic departments need to hire. We need faculty to teach these courses. We need people like you guys who have these skills, have the quantitative analytical skills, have the domain area expertise to come and teach others. And so what we see is that there's a lot of these new programs, but a huge number of them are within business schools. You know, these are topics that you might think are more engineering, but really a lot of the programs that are being offered are within business schools. So a lot of these new jobs that I'm talking about for new faculty are in business schools. So again, if you're even thinking about an academic career, considering business schools will really broaden your opportunities. So just some examples of what I'm talking about. So this is from just about a week ago, an article in Bloomberg. You know, it used to be when you did an MBA, everybody wanted to study finance as their focus in their MBA. And what this is saying is, you know, that's not the case anymore. Supply chain management is where it's at when you're getting an MBA. And this is just sort of demonstrating the interest that students have suddenly in this area of supply chain management. The next one looks at the analytics side. The graph there is actually from your Institute for Advanced Analytics at NC State. And you can see the growth over time, particularly in the last 10 years, of these analytics master's programs. And if you look at sort of the orange color band that's there in the middle, those are business analytics programs. So those are growth in analytics programs, specifically in business schools. Some of those data analytics would also be within a business school. The data science ones are more likely to be outside of a business school. But you can see this huge growth in the number of programs. And that means more students, more courses, needing more faculty. And then the table at the top, it's just giving some numbers about growth. It uses the acronym DSA, that's data science and analytics. And what they're predicting is, you know, 15% growth in the jobs. So this is the market, right? The students are seeing this growth in the number of jobs out there, and they want to position themselves to take advantage of that. So I'm going to talk a little bit about my background because I think it's going to be a useful reference when talking about this different career path in business schools versus engineering schools. I won't spend a whole lot of time. I'll go through this a little bit quickly, but in terms of, you know, education, my undergrad degree is actually in mathematics and the social science. It's a field that's now typically referred to as quantitative social science. And what it is the application of mathematical computing techniques to other fields. I particularly applied it to political science, but you could apply it to history or geography or economics. And it really is just demonstrative of this idea that I'm a big supporter of being interdisciplinary, right? And in particular, I'm a big supporter of thinking about, you know, these quantitative tools that all of us have. How do we apply them to solve real problems, right? In other fields. And so that's my undergrad, and then my PhD is in industrial engineering and management science. And I also do have industry experience. I started out working largely in healthcare, and actually this is before everybody was doing healthcare. This was in the 1990s. And then as I started getting involved in supply chain management, I moved into jobs that were more focused on retail, right? So I worked for Sears Roebuck at their corporate headquarters, working in supply chain management. So at the time, they were a successful major retailer, not so successful anymore. So a little bit about my academic careers. After I finished my PhD, you can see I've listed them sort of in order there. I was an IE for a while, and then I went to a college of business, and then I went to another college of business, and then back to industrial engineering, and now I'm in a business school. So that's sort of the context that I think is important for what I'm going to say, is that your degree that you're getting is very flexible, right? You can fit in different places, and I'm going to talk about the differences between engineering and business and help you to think about which is the good fit for you. Currently, I am faculty and chair in the Department of Supply Chain Management and Analytics at the University of Nebraska-Lincoln. One thing to understand is that we are a new department. We launched in 2016. I was the first department chair, and we kind of replaced the industrial engineering department. There was an industrial engineering department. It was rather small. They got rid of it, and then a few years later, they started this department. So a lot of the content that we teach is quite similar to what you would experience in an industrial engineering program. You guys talked a little bit about my research interests. I'm not going to repeat what was said. What I'll just highlight is, that first topic, supply chain management, inventory management. That's a topic that can fit in either business or engineering, right? You'll find people doing research in those areas, either place. In terms of the second topic, which is really design and analysis of sourcing and procurement mechanisms, that is typically going to be more of a business school kind of topic. It's a lot of game theoretic analysis and mechanism design, so it tends to fit a little bit better in a business school. The final topic there, pricing and capacity management for wireless systems. This is more of an engineering kind of topic. And this is current work that I'm doing, and it's collaborative with people from computer science and engineering. Again, my research tends to span both engineering and business. And a little bit, it varies according to what type of institution I'm at. The publications, one thing I just wanted to highlight is I've published again in engineering journals. So IISE Transactions, IEEE Transactions, journals like that are more traditional in engineering, but also in the more business school side, production and operations management, MSOM, and so on. So I know a little bit about the processes for publishing in both types of places. And then, in terms of research, the other thing I'll say is that unlike most business school faculty, I actually have experience with funded research. I understand the importance of funded research. I understand the challenge of getting funding to do research. And that's something I'll talk a little bit about, how that differs between engineering and business. So teaching is, also important to understand. I've done teaching in both locations. And to be honest, the content isn't all that different, right? So, I've taught logistics at both types of institutions. I've taught, designing supply chains at both types of places. The main place where the teaching is different, as I've done more like statistics and stochastic processes, theoretical kinds of things, and in a more engineering environment. I've also placed students, PhD students in academia. So I have 5 students who have been in academia, and they're roughly equally split between business schools and engineering. So again, I'm just trying to demonstrate the flexibility. All of these PhD students who went to academia, they have IE PhDs. So their PhDs are in industrial engineering, either from Purdue or from RPI. But 3 out of the 5 who went to academia went to business schools, okay? So these really are positions that are open to industrial engineers. Last thing I'll mention, as you'll see when I organize my discussion of the differences between engineering and business, I'll focus on teaching, research, and service, right? And so my background is organized the same way. I just want to highlight here the different kinds of service activities I've done, and I'll revisit this idea that depending on where you are, whether you're at a business school or an engineering school, you're going to tailor the type of service activity that you pursue to what's valued at that type of institution. And I'll come back to that idea. So, what kinds of professional societies you work with will depend on whether you're at a business school or an engineering school. For example, the types of journals that you choose to referee for, review papers for, will depend on where you are. So just some caveats before I get started. A lot of what I'm going to say is based on my personal experience. I hope I've conveyed to you that I've got a lot of experience that allows me to compare the two environments. But my most recent experience is in a business school. So, I know that more right now than the engineering side. So maybe some of you can correct me when I say things that are maybe outdated. The other thing to keep in mind, there's a lot of variation across universities. Every university is different. So, I'm not going to necessarily say things that are applicable, that are 100% correct in every environment. Okay, so before I get going, this is a good place to pause and see if you guys have any questions. I can't see if there's any hands raised, so people are just going to have to speak up if they have questions. There's two things in the chat, actually. Okay. Oh, Julie's there. Hello, Julie. Okay, so in terms of academic careers, right? So that's what we're going to start with, academic careers. What kinds of departments are hiring? So you guys are all industrial engineers. So you might be familiar with the variety of names for departments or schools of industrial engineering, and there are a variety. There's also a similar variety, maybe even more variety in terms of business schools. So just some examples. These are just example department titles. And this is important because if you are thinking about maybe pursuing an academic career, you want to know what kinds of places to look, right? If you see a job ad, you want to know, is this something I could apply for, right? And so you can see the wide variety of different kinds of titles that they have, on both sides. Another thing I would point out is that, in some cases, on both the engineering side and the business side, what we do gets lumped in with other stuff, right? Because industrial engineering departments are often small, not always, you guys aren't small, but many of them are, because supply chain management, operations management departments are often small, we get lumped in, right? So sometimes you'll see marketing and logistics in a business school, right? So the supply chain people get lumped in with the marketing department. As I said, at Nebraska, we used to be part of the management department. So we get lumped in. So in engineering, you sometimes see that industrial engineering is within the mechanical engineering department. So there are mechanical and industrial departments out there. So, that's a challenge on both sides. And then, to be a stepchild or whatever is never fun, but it happens. So, keep that in mind. So I want to talk about expectations for faculty, how the job differs. And again, in each case, I'll compare business versus engineering. And I'll start with research. So I'll do research, teaching, and service. Those are the elements of a faculty member's jobs. That's how we define what we do. That's how we get evaluated on research, teaching, and service. So one of the big differences is publications. In a business school, it's not about numbers. They don't care about numbers. They want quality. And so typically at the elite, at the best schools, you'll see one high quality publication per year. And I know that doesn't seem like a lot, but getting something in OR or management science is really, really challenging. So typically it's one really high quality publication per year, whereas in engineering, you're going to see more publications in different kinds of journals. And you'll see more things like proceedings, right? And so depending on the branch of engineering, proceedings may count. I know they count a lot in computer science and engineering, but in some branches of engineering, they count, but not for a whole lot. In business, they don't really count at all. They don't care. So we don't spend our time doing that. And the major conferences don't do proceedings. So the other main difference besides publications is, of course, funding, right? So funding is essential in engineering. You have to be writing grant proposals all the time. You have to bring in money. And, when I was in engineering, what I was told is that how we define and measure quality is funding. if people don't want to give you money for what you do, it's not high quality, it's not important, it's not relevant. And that's very, very different than in a college of business. In a college of business, you don't have to worry if somebody's willing to give you money for what you do. You have to worry about whether it will be published in one of these top journals. So quality in a business school is defined according to the journal. And we have lists, right? And so this, when you talk about like an A or a B journal, there are actual lists that are kept at most colleges of business. Some places won't admit it, but typically they have one that define these are journals that we count and these are journals that we don't count, right? And so for these days, a lot of the colleges of business, they define their A list based on what's called the University of Texas Dallas Journal List. They have a list of the top journals in each area of business. For our field, it would be management science, operations research, MSOM, production and operations management, and the Journal of Operations Management. For MIS, which is another related area, it would be things like MISQ or ISR. And basically in a business school, you have to publish in whatever those A journals are, whatever journals are on that list. If you want it to count, if you want to get tenure, that's what you have to do. It's not about the dollars at all. It's about where you publish your work.
Dr. Ryan,
yeah, absolutely.
A quick question on this publications, especially you said for a B schools. Of course, we understand when you say A publication, you included operations management, the POMS, MSOM, and so on. But there are top A journals, I mean, which is exclusively from both engineering and management together. So will be considered for a B school, for example, let's say IJPE, or let's say EJOR. So these kinds of journals, I mean, they are top class, of course, but they don't focus heavily on management only. They focus engineering and management science topics. So how do you,
Yeah, and so that's where you're going to see a lot of variation from school to school. So each business school is going to have its own list. EJOR shows up as an A or A minus on quite a few lists. IJPE shows up on fewer lists. So you're gonna have a lot of variation. It's going to depend school to school, and that's something that typically job applicants ask about, right? If you have a sense of where your research fits well, if there's certain journals, you should be asking about that when you talk to people about jobs. And the other thing is, once you arrive, you want to understand what the expectations are, and then you want to tailor what you do, because it's very different to write a paper for management science than it is to write a paper for IJPE. How you write the paper, the type of analysis you do is going to be different. And so you need to recognize that and adjust. But I would say it's very rare for IJPE to be on an A list. It's not unusual for it to be an A or A minus for EJOR. Yeah, so there is variation. Other ones that sometimes show up are decision sciences, IISE transactions. They sometimes will show up in the A list or A minus list. Yeah, and it's not that the other ones don't count. It's just that you need to have some sufficient on the A list. So the others do count. So for example, we have both what we call our summer research support list, because it's how you get summer support, which is our A's. And then we also have a department list. So the department list has 25 journals on it. IJPE is there, IJPR, right? IISE transactions, those are all on there. So the department list counts, just not as much.
Oh, so that means a follow-up question would be, let's say if someone is clearing tenure in, let's say, 6 years in a B school, they should have at least 6 A publications, because A publication per year, 1, right?
Well, that's at the elites. We typically our candidates will more likely have 4.
4. Oh, okay, nice.
But that's going to vary. I mean, if you're looking at the really top 10 business schools, yeah, 1 per year is pretty typical. But yeah. And we can make the case, right? So it's as a department chair, when I write letters for tenure, my job is to make the case, right? If I support a candidate, if they have a publication and something that's not on the list, I can certainly make the argument that it ought to be considered. This particular paper there is highly cited, or this journal is special for this reason, right? So there are exceptions, of course.
Oh, okay, thanks.
Yeah. Other questions? So the last point on this slide is in interdisciplinary work. My own personal experience is that both engineering and business schools will say that it's valued, but I think they mean it more in engineering. They value the interdisciplinary work more. So if that's important for you, that's something to keep in mind. That doesn't mean that it doesn't fit in a business school. I do a lot of interdisciplinary work, and you know, it can fit. It's just not valued as much. So another big difference is PhD programs. And I'm going to put this out there, and I'm going to say this is important if you're thinking about taking faculty jobs. But I know also I've talked to many students doing a master's in IE who think about, I want to get a PhD, but I'm thinking about maybe shifting to business. So this is some information for those students as well to help you think about, you know, do I want to do a PhD and what kind of program is right for me? So there's a big difference in size typically between PhD programs. Engineering programs tend to be a lot bigger. A lot of the business school programs are quite small. We admit for each program within the College of Business 2 students per year. So that's quite small. And one of the big drivers for the difference in size is funding. So our faculty don't bring in funding for students. This funding is provided entirely by the college. So we bring in a student, the college commits to funding them for 5 years towards their PhD. Whereas in engineering, right, you might have funding for the first year or so for a student, but after that, you've got to provide your own in many cases. And so the number of students will be determined by the level of faculty research funding. But typically faculty want to have at least two students of their own, right? Not 2 per year for the whole department, but at least 2 of their own, right? So there's a big difference in size. The funding issue also makes another difference in an engineering school because you're reliant on your faculty advisor for your funding. In many cases, you do your work with your advisor, period. Right? You might, you're going to have a committee and you might have collaborations with your advisor and other faculty within the committee, but you're going to work with your advisor. In a business school, it's much more common to see people working with multiple faculty. So I might have a paper with my advisor, but I might have a different paper with another faculty member and a third paper with another faculty member. Of course, you have to have an official dissertation advisor, but it's much more common to work with different faculty in a business school because you're not tied to the funding. You're not obligated, right? You're not getting your funding from one particular person and therefore obligated to work with them. And so that's very different. Because of the small size, we tend to offer less coursework in a College of Business. And we compensate by leveraging industrial engineering coursework, right? So if you're studying supply chain management at a business school, you'll very often have, for a PhD, you'll very often have to go over to the IE program to take your coursework. And that's not a bad thing, right? That's a good thing. If there's no IE program, you might be leveraging math to take stochastic processes or statistics, right? Related programs. You might find your queuing course over in computer science. And so you typically will have to have less courses offered within the College of Business. You'll be taking more outside of the college. And the other thing is you're probably going to take courses in accounting, finance, marketing, right? So you're going to probably take seminars across the whole domain of business. Another big difference about PhD programs, and this is really particularly important for those of you who are thinking about, you're a master's student thinking about doing a PhD, would be that in a business school, we only train to be academics. We train students to be faculty. We do not train them for industry careers. And that is very, very different than in the IE program, where probably most students go to industry. If we look at placements in a business school and we want to say, do we have good placements or bad placements? It's all about academic. We want our students taking academic jobs, right? And so obviously that's really important if you're thinking about doing a PhD. If you're going to go to a business school, you have to be pretty sure you want to do an academic career. Teaching expectations. In a business school, standard load is 4 per year. In an engineering school, it's typically, my experience is 3. Pre-tenure faculty in both kinds of schools typically get a course load reduction, a teaching load reduction. So standard load would be 4 in a business school, but none of my assistant professors teach more than 3 courses per year. And my experience is something similar happens in engineering. You go from 3 down to 2. What's quite different is after tenure. So after tenure in a college of business, what's becoming very common is to have a system for getting a teaching load reduction based on your publications. So again, we have this list of A journals. If you publish the right number in the A journals, maybe we'll only give you 3 courses a year. We won't make you teach 4 courses per year. So you're rewarded for your research output. Whereas in engineering, there's a mechanism to get a reduced teaching load, but it usually involves buying it, right? So you bring in funding and you have to pay for a course release, is what they call it. So you can reduce, and again, it's based on your research output, but it's dollars. You typically also, pre-tenure faculty and a business school will focus on undergraduate teaching, and that's because our MBAs can be kind of challenging to teach. And so I think this is changing a little bit. But typically you're going to see more teaching of undergrads. Whereas my experience, the assistant professors in an engineering school, they'll teach at all levels. They'll have the opportunity to teach master's and PhD students. Just to give you a sense of what teaching looks like at a college of business, I know you all are aware of the courses that are offered in an industrial engineering program, but in a college of business, it's a little bit different. So on the left of this slide, I have the list of the types of programs that we offer, and that dictates, of course, the type of courses that we offer. And I'll show you some course names just to give you a sense. We have an undergraduate major in supply chain management. We also have an undergraduate minor in business analytics. Then we have master's programs in both of those areas as well. So those are MS programs. We have our PhD specialization launching next year. So we don't currently have PhD courses, but we will next year. And so in addition to that, we offer core courses. So these are courses that every student in the College of Business, undergraduate student, has to take. So regardless of your major, so if you're a finance or accounting or marketing major, you have to take 2 things from us: the core operations and supply chain management course, basic intro course, and similarly the basic intro business analytics course that we teach. And then I just also on the right, I just gave you a sense of typical faculty. We have 12 faculty in our department. So again, these the departments tend to be a little bit smaller than maybe you're used to. So we have 12 tenure track faculty. A quarter of those have IE PhDs. So again, not unusual at all to come into a College of Business with an IE PhD. So here's some sample course titles, just to give you a sense. And what I actually want to demonstrate with this is there's really not that much difference between a lot of the courses you would see in industrial engineering and what you would see in a department like mine. So on the left, you have the more supply chain operations kind of courses, right? We teach production planning and control. I'm sure you guys have production planning and control. We teach logistics. You guys have logistics. We teach project management. You guys have project management, right? So there's not so much of a difference in terms of the courses. And these supply chain courses, this is why I really like to hire industrial engineers, PhDs in industrial engineering, because I need somebody who can teach this variety of topics. At some of the very, very elite business schools, they don't learn this stuff. The PhD students in operations, they don't learn production planning. They can't come into a classroom and teach MRP. They can't, but an IE can, right? So this is why there's value. This is why, don't sell yourself short. Business schools might actually be very attracted to an IE PhD because of the flexibility you offer to cover this type of course. Especially, programs like ours that have a full major in supply chain management, they need that kind of expertise. On the right-hand side, you have the business analytics advanced courses that we teach as part of our undergraduate minor. And again, a whole host of sort of quantitative topics that probably a lot of you are familiar with and could handle. A lot of it's sort of OR-based courses. So that first one's the decision-making models. That's our linear programming course. We don't call it linear programming. That would scare away the students. But supply chain decision-making models, it's linear programming. We teach statistics. We teach data mining, the predictive analytics, right? Data mining. We teach simulation and risk management. So simulation, a little bit of queuing. So the data modeling and computing, it's an R programming course. So, these are not so different than what you would see in an undergraduate IE program, it would be my guess. service. You know, I would say that the service expectations for new faculty are pretty low at both. My experience is that it's lower at an engineering school, but it's not a huge difference. And I think the main thing I want to say about service is that service should align with the expectations for research. And I said this before, right? So the journals that you prioritize when accepting invitations to review a paper are going to depend on whether you're in a business school or an engineering school, right? You want to be reviewing papers for journals that are going to count or help you, right? So if you're in a business school and you need to be publishing in these A journals, what's going to help you is to review papers for those journals so you can understand how papers are written for those journals. Similarly, you know, if you're in a business school, the conferences you want to get involved in terms of organizing sessions, for example, you're going to want to get involved in the ones that are valued more in the business school, or where you're going to have more attendance by business school faculty. If you're on the engineering side, you're going to want to get more involved in the conferences that are on the engineering side, right? So you're just going to tailor your focus of your service activities to the environment that you're in. Okay. Money, right? Money is really important. Salary, summer support, startup packages. So what I did, we have done some salary benchmarking here at Nebraska. So I had some data. I had data on some large state schools that offer good supply chain and operations management programs. So I picked one of those. I won't say which one it was. And I picked one that also has a really good industrial engineering program. So I picked a large state school that has very strong operations and supply chain management in the business school and very strong industrial engineering in the engineering school. And I already had the data on the business school faculty. So I just went and I got the data on the engineering school faculty. Okay, this is all public in a lot of states. So you can see the salary ranges there. So this is really where there's a huge difference, and why maybe is my strongest selling point for why you should think about going into a business school, right? Quite a significant gap in salary. I didn't put full professors here because it's really hard there, because a lot of full professors will have administrative appointments, and then that distorts the data. But if you look just at the assistant professor data, I think you'll get the point of how quite, $70,000 difference basically in starting salaries per year. And these are comparable. These are 9-month salaries, not including the summer. So huge difference. Summer support, there's differences as well. So typically, if you're new, both types of positions will offer you summer support. They'll say, we're going to give you 2 nights, so 2 months worth of salary for the summer. Or in some cases, particularly at business schools, they'll say, we'll give you X dollars for the summer, okay? So typically at the beginning, you're going to be guaranteed some summer support. But then after that, that's where it changes. So in an engineering school, you're self-funded. You get a grant, you pay yourself out of that grant, right? And how much you pay yourself, how many months worth of salary you give yourself, depends on how much money you've brought in. In the business school, it's based on research output. So typically we've got our list, our A journals, right? And there'll be some kind of rolling horizon. We want to see 1 publication every 2 years, or 1 publication every 3 years, or whatever it is. And that's going to tell us how much summer support we'll give you. And, different universities do it differently. Some do it week by week, right? So it's a very fine gradations depending on how many publications you've had over how many years. But typically these workload models that they have in business schools will dictate how much summer money we give you, how much we pay you for the summer based on your publications in these top journals. So it's research based. So everything, teaching load, tenure, summer support, all driven by these publications. So that's the #1 priority. Startup packages also differ, in engineering, because not so much industrial, sometimes industrial, but because other branches of engineering often need really quite significant equipment that's very expensive, startup packages are more common, right? That you'll get 20,000 or whatever it is to build your lab. We don't have those in a business school. You get the basics, right? You get your moving expenses, you get your computer, but you also get annual funding. And so again, my experience is engineering will do this as well. For the first couple of years, we'll give you some travel money, right? You need to travel, we'll pay for it. First couple of years, we'll give you some what we call professional development to pay for your, professional society membership, books, whatever it is. But then in engineering, again, after a couple of years, self-funded. You got to bring in your own travel money if you want to go to a conference. In a college of business, it's pretty much guaranteed that the college is going to provide this money. You don't have to bring it in yourself. And so I put down the dollar values that our assistant professors get. It's going to vary from college to college, but we guarantee 4,000 travel and plus 4,000 professional development per year for our assistant professors. Of course, when we have budget crises, that goes away, or part of it goes away, but that's our standard offering. So quite a bit different on the monetary side of things. Last thing I think is about differences in terms of the recruiting process. So another big difference is teaching. So I didn't mention this when I talked about PhD programs, but in PhD programs in a college of business, you're going to be expected to teach. Typically, you'll be expected to teach at least twice towards the end of your time. And depending on the college of business, depending on the university, it could be more than 2, it could be 4 times. You might have to teach every semester your last 2 years, for example. So teaching is an expectation for PhD students in business. And it's an expectation when business schools look to interview candidates for faculty positions, they want to see teaching experience. And that can be a challenge for somebody coming out of engineering because they often don't have the opportunity to teach. I've been at places, so for example, at RPI, they did not want PhD students teaching, period. So it was very hard for our students to get the teaching experience. There are ways that you can do it, but you have to be creative. Another major difference about the interviewing and recruiting process is the job talk. Typically an hour for engineering, typically an hour and a half for business school. And the questioning, the Q&A tends to be a little bit more challenging in a business school. They really test you in these job talks. It's also typically a higher expectation that you submit a working paper as part of your interview for a business school than an engineering school. It's a good thing to do for both, but typically a higher expectation for that. And because the focus of a business school, everything I've talked about, so much of it is driven by research publications, right? Tenure, summer support, teaching load, all driven by your research publications. They're going to want to see that you can do that, right? So that means they're going to look at your CV and they're going to want to see that you have a publication already, or that you're close to getting one, right? So they're not going to just trust that you can do it. They want to see that you can do it. And that's very different from engineering, where not everything is driven by the publications. They might be more interested in hearing about your experience in helping your dissertation advisor write proposals, right? That might be of more value to them in an engineering environment, just because that's what they value. They value the ability to bring in funding. So it can be quite different in what they're looking for. So again, this is something to keep in mind if you're thinking about applying, that you do need to demonstrate the ability to publish, and that takes some time to do. So it's not a last minute kind of thing. It can take a year or 2 to get a paper started in the review process. So,
Ryan, a quick question.
Yep. Mm-hmm.
In the previous slide, you were saying about first bullet is about teaching experience, isn't it? If someone from engineering school comes, we really know that they don't have enough teaching experience. So how do business schools evaluate that? Right.
So that's tricky. We would say, okay, have you been a TA? And what was your job as a TA? Did you lead a discussion session? Did you lead review sessions, right? What can you document where you actually were in front of the classroom teaching content? And in many cases, the PhD students who are TAs, they do have the opportunity to do those kinds of things. They might say, hey, did you have an opportunity to go teach somewhere in the summer? Was there a local community college where you went and you taught algebra for the summer, right? So you have to get creative, because they will want to see something to document your teaching ability. If you look at how job descriptions are written for business schools, they will very often have minimum expectations that include some kind of teaching experience. And if you don't have anything, if you have nothing on your CV, you're not going to get an interview. So you have to think about what can you do and what can you document to show that you have some teaching experience. And it may very well involve in looking at other institutions to teach. Can you go to the smaller school next door and teach a course for them? Yeah.
Thanks.
Mm-hmm.
Dr. Ryan, I had one question. So I am an MSI student, Masters of Industrial Engineering, and if I wish to teach in business school, so how should I plan my professional journey? Because when I discussed with several professors, some of them suggested me to get some industry experience and then come back to academic side. So what's your opinion on that?
Yeah, I mean, and I have that here, the work experience is highly valued, I think more so in a business school, because eventually you're going to be in front of MBAs who have 5 or 10 years of work experience, right? So you want to have some credibility. You don't need to have a huge amount of work experience. You just need to have enough to give you some stories, right? And you can repeat your stories to different students, right? So, and then hopefully, once you start being a faculty member, you're still interacting with industry, right? You're still gathering up the experience and you're still gathering those stories. But a couple years of work experience or a few really interesting internships even can be enough. But you want to be able to leverage your work experience to relate it to your teaching. That's really the main thing. You want to be able to convince people that you're talking about something relevant in the classroom because you actually used it, or you can relate it to a problem you had when you were working.
Yeah. Thank you.
Mm-hmm. So the last thing I'll say is, I've been talking about, everything I've said is really focused on tenure track faculty. There's a whole other class of faculty out there that some of you might find attractive. So, the world has changed where it used to be, everything was tenure track, and then there were these adjuncts who got paid to teach one course at a time. And that's not the world anymore. The world now is that we have teaching focused faculty as a career path. Right, so you can take a job as what's known as a clinical faculty member, or we call them professors of practice. Some places call them lecturers, where you teach. You're not expected to do research. You teach more, but it's a career path in the sense that there are longer term contracts. You're not contracted for 1 semester at a time or 1 course at a time. You're contracted for 3, 4, or even 5 years, and there are opportunities for advancement. Right, our professors of practice have ranks. There's assistant, associate, and full. And as you progress in those ranks, you get longer term contracts and you get higher salary, and you get more responsibility. We have professors of practice here and in quite a few other places that have moved into administrative, right? So they might be assistant or associate deans for undergraduate education, that kind of position. So if you're interested in an academic career, but your love is not research, your love is teaching, that's the role for you, that there are opportunities there and they are growing. Because these faculty teach more and because we have such a need to staff all of these new courses, there's a lot of these teaching focused kinds of positions. I know they exist in engineering. I think they're more common in colleges of business. But we have one and we're hiring for a second one. So we have 12 tenure track faculty plus 2 professors of practice, basically, and that's low. Actually, I think other departments would have a higher fraction of their faculty would be on this teaching side of things. Yeah, and because they do contribute so much to the mission of the college in terms of teaching, they are highly valued. They do sometimes feel like a little bit like second tier because they don't do the research, but I think there's a sense that they're very, very valuable in terms of what they bring to the students and to the college. So I'm going to transition to the second part. I don't know if there are any questions before I do that.
One question on this teaching focused faculty you mentioned. If suppose for a tenure track faculty, there is an evaluation process and based on certain publications and other things, for teaching, how this evaluation could affect them? Could you just throw some light on that?
Yeah, that's a very good question. And I think it's going to differ a bit from college to college. I can tell you what we do. We do a formal review process for both tenure track and a teaching focused faculty every 3 years. And then for promotion, as I said, you can go from assistant to associate to full professor of practice. We do a full process, just like it actually goes to exactly the same committees, just like for tenure and promotion. The only difference is the criteria. So we talk about apportionment, which is how your duties are broken down. So typical tenure track faculty will have 40% research, 40% teaching, 20% service. Whereas for a teaching focused faculty, it'll be more like 80% teaching, 20% service. And so we evaluate faculty based on their apportionment. So if you're 80% teaching, we're not going to look at research because you don't have research. We're going to look at teaching. But we still go through the process of, for example, requiring you to write long 5-10-page statements about your teaching, about your service. You don't write about your research, but you write about your teaching and service. We still expect a quite detailed CV that outlines everything that you've done in terms of your teaching and service. We expect service outside of the university. We still want you to be involved in professional societies. We want you maybe writing papers for educational journals. We want you maybe attending educational conferences, organizing sessions at educational conferences, writing case studies, writing textbooks, right? There's lots of stuff you can do besides teaching that is appropriate for a teaching focused faculty. So we look at all of those things. The other thing we do is we also get external letters, just like you would for a tenure track faculty. You ask people to write from other universities to write letters evaluating them. We give the full package, right? We give grade distributions, teaching evaluations, course syllabi, teaching materials, exams, homework assignments, case studies, all of that. We give this big package to these external letter writers and ask them to write a report. Would you promote this person? And so it's a very rigorous review process, just like for tenure track. And the goal, at least for Nebraska, every place is different, but at Nebraska, the goal was really so that tenure track people respect the promotion of the non-tenure track people, because they know it's just as rigorous. The process is just as rigorous. So we should be so respectful for the people who make it through the process, just like we're so respectful of people who get tenure. If you get promoted to associate professor of practice, we respect you for what you've done. We see that as a huge accomplishment because it's such a rigorous process.
Thanks.
Mm-hmm. Other questions? So the next part of my talk really gets at this transition that some people make to industry jobs, right? So if you're going to go from, say, an MS or a PhD in industrial and systems engineering, very often you're going to end up in a job that's more on the business side of things, right? You might end up working in operations or supply chain management. You might end up working in business analytics if you've got these quantitative skills. And how do you make that transition? What are some tips for doing that? And so what I really focused on here is, suggestions for how to prepare, or what you can do to better position yourself for these more in management oriented or business oriented jobs, and which is really a lot of them, right? A lot of the jobs that an MS and IE might get are going to be in a corporation doing something where they have to interact with other people from accounting or finance or marketing, other areas of business. You're not just going to be interacting with other engineers. You're going to be working hand in hand with these people with more business background. So just my suggestions related to this, build your knowledge of business, right? So you need to know how to speak the language of business. And, industrial engineers are usually pretty good at this, more than, say, other kinds of engineers, but often there's work to be done to learn the language, right? What are the terms that they use in accounting and finance? You need to understand those terms. You need to know a little bit about every aspect of business, HR, marketing, all these different areas. So how do you do this? And that's a good kind of question to think about, because it takes some time to prepare for that. you can take business courses depending on what they allow at your university. If you're allowed to, go over and take a business course, right? To get some background in some of these other functional areas of business. Sometimes you can do what's called a graduate certificate. So this is not a full degree program, but our graduate certificates have 4 courses in them, and you get certification that you completed it. So you could do a graduate certificate in entrepreneurship, if that's what's important to you, or you can do it in human resources. And so it gives you the credentials. You can do your MS in industrial engineering. You can go get an MBA, right? And that's certainly a way to do it as well. The other thing I'll mention is in some universities, and I don't know what you guys have, but they had this at Purdue when I was there. They actually offered, there were so many PhD engineers graduating from Purdue that were going into industry jobs that they had like a week-long, they called it a bridge program, where it was free for the PhD students to go, and they got a 1-week intensive training in business, basically to cover all of these items that I just mentioned. And it was a great opportunity for them to be able to strengthen their business credentials before entering the working world. And they did this because they realized it was so important. If these PhD engineers graduating, going into the job, are going to be successful, they have to have these basic skills, right? So they were helping prepare their students so the students would do a better job and be more impressive when they got out there. And the other thing is, obviously, if you want to work in industry, you got it's great to get internships. If you might have the opportunity to be funded on your research for the summer, working on your master's thesis or whatever, that's great, but it also helps to have an industry internship. So that's something you should think about, whether you can do that. Just again, to get the experience, to learn how to interact with people, to have things to talk about in interviews when you're graduating. So you want to build your knowledge of business, but you also want to make sure that you're developing your expertise in your target industry, right? So hopefully you have an industry in mind that you're thinking about, and hopefully it's somewhat related to the research you're doing or the courses you're taking in your master's or your PhD program. And so you want to build your expertise beyond just your coursework. So you want to be hired because you're the guy who knows everything about this industry. And it can be, for an IE, it can be quite diverse what that is. You might be on the manufacturing side, so you might be an expert in certain manufacturing technologies. It might be transportation, could be healthcare, depending on who you're working with, right? So there's lots of different areas to focus on, but you want to become an expert, and you want to try to demonstrate your expertise to potential employers through your resume, right? So you want to have the right kinds of activities on your resume to highlight, right? So whether it's being involved in a club or participating in certain conferences or taking certain kinds of courses, whatever it is, you want to demonstrate this to the employers, that you have this in-depth domain knowledge. It's not just about the engineering coursework, it's understanding a particular application area. So again, related to this, you want to preparing for a career in business, you want to leverage your existing skills and also develop new skills. So it's really interesting. Just yesterday, I had a student in my office, one of our supply chain majors, graduating in December. He's got a job that he accepted at an engineering firm. They build satellites, right? So he's like, how do I make this transition from everything I've been learning for the past 4 years is business? How do I make the transition to engineering? All these guys I'm going to be working with are engineers. How do I be successful in that environment? And I would tell him the same thing that I would tell you guys is, leverage your existing skills, build up where you're missing, right? So on his example, he was missing the engineering skills. So I told him, you got to learn how to read an engineering design, right? You got to learn the language of manufacturing. You need to develop the ability when you go, he's going to be working partly in procurement. When you go into these suppliers and you're on their manufacturing line, you have to know what you're seeing. You have to understand what a lathe is or whatever, right? You need to know what you're seeing when you go and visit these or when you talk to these engineers on the floor, right? So you need to spend your weekend reading about satellite design, because you're not going to be an expert. You don't have an advanced degree in that, but you need to be able to talk to the people who you're going to be working with. And by doing that, by investing the time to develop those skills, you're showing that you care, right? They're gonna treat you differently if you've demonstrated an effort to meet them halfway, to learn their language, to learn what they do, to respect what they do. They're going to value you more if you show that effort. And so I would say the same thing here. It's exactly the same thing. It's just, swapped, right? So you've got existing skills. You want to highlight those existing skills and you want to leverage them, right? And that might mean building them even more, right? If you're good at coding, make sure you know the right languages. Make sure you know the languages that are in demand, right? That might not be what you normally use for your research, but you could do it on the side, right? So you want to build, you want to leverage your quantitative ability, your computing skills. Typically, engineers have good problem-solving ability. Typically, they have good, attention to detail and time management. Figure out how you can highlight those things. Those are things that not everybody has, right? But engineers typically do, right? We don't always train business students do project management. That's something engineers often have to do. They often have good skills there, right? So think about what it is that you bring to the table, and then how can you enhance it, and how can you highlight it? And then develop those new skills, right? So, you're going to be going out, you're going to be working in the business world. As I said, you're going to be interacting with people from all kinds of different areas of business. You need to be able to talk to them. And so just like with your existing skills, there's going to be hard and soft skills, right? The soft skills are these communication skills. You need to be able to speak properly, to write well, and to give presentations. You need to be able to do that. I'm going to show you some slides in a second to sort of highlight why this is number one on my list. But there's also, you need to be able to work in teams and collaborate with people from other areas of expertise or functional areas of business. But then there's some harder skills like negotiation. Negotiation is not just about being personable. There's a process to negotiating. If you want to be a good negotiator, you got to learn that process. Similarly for selling, right? So those are things where you can be trained. You can read. You can learn how to do this. Can you read a financial statement, a balance sheet, an income statement? Learn how to do that, right? You need to know how to do that if you're going to go into business. What goes, if you're a more entrepreneurial person, what goes into a business plan or a project proposal? It's very different than a research proposal, than a grant proposal. So learn how to do that. So there's really specific skills that you can develop to help you position yourself better in the industry job market. So I highlighted the communication skills. I have a couple slides here, a couple graphs here that I'll just show. So this is, you see the reference down at the bottom. So this is a study that looked at job ads, and these were in analytics. Okay, so not industrial engineering, but analytics, but I think it's pretty similar. And it looked at job ads, the keywords that were in the ads, right? And you can see the top 4 that I highlighted there. Communication, interpersonal skills, managerial skills, right? Teamwork, communication. Database, okay, fine. That's important for analysts, right? But business domain. So again, this area of expertise, figuring out what industry you want to work in, and then building up your understanding of that industry. If you're going to go work in transportation, you need to know a whole lot about what's going on today in trucking or whatever it is. So that domain area expertise, really important. And I listened to a session at a conference for people who direct programs in analytics. And they had an employer section. Okay, so the employer is talking to people like me who design programs or run programs. And what they said is, we can train people to code in a certain language, right? But what we can't give them are these things, right? And so what we would rather take somebody who has a real good understanding of our business, who's got demonstrated ability to think logically, to do quantitative analysis, and then give them the specific skills that they need. I mean, these days, right, there's just so many different kinds of software that are used in analytics. You can't expect to hire somebody who knows exactly what you use, right? So they realize they got to train you in it. But what they want to see is what you bring to the table in terms of these things, right? Good communication skills, good business domain knowledge. And then, demonstrating that you will be able to learn what they want you to learn. Last slide I'll show is, this is same source, but this one they looked at job ads from a wide range of different kinds of jobs. You can see nursing, teaching, accountant, sales associate, industrial engineer, analytics, or data science. And they said, okay, what percentage of those job ads used communication or interpersonal skills as something they were specifically looking for in candidates? And they ranked them. And you can see that when looking for an industrial engineer, communication skills more important than when looking for a nurse or a teacher. And that's not true. It's not more important, but they felt the need to highlight it because they feel it's something that's often lacking. And that's the interpretation here. That if you can tick this box, that you can show that you've got the interpersonal skills, the communication skills, you're going to rise to the top of the pool of candidates if you're in these fields like data science, analytics, industrial engineering, right? Obviously, these skills are super important if you're in sales, right? But they find people in sales who have these skills. Apparently, they don't find that many people in industrial engineering or analytics that have these skills. So that's really a way to make yourself stand out in the job market. Okay, that was my last slide. So yeah, we have some time. I'm open for questions.
Maybe I'll start with some questions for our master students. So we are from industrial engineering. Of course, I'm a PhD student. I'm asking for master students' benefit. So someone without having any industry work experience, they come here for master's degree in industrial engineering. When they apply for job in the industry, they will be competing with those who have MBA in business operations, supply chain management, who has MS in analytics, who wants to be in supply chain analytics. And then there will be some people with the master's degree in statistics and mathematics who work heavily on optimization, statistical analysis, and so on. So any tips from your perspective, your experience for IE master students, how they should project and they should look for by honing their skills and to take up that career? Because they are going to compete with so many competition in the industry. So what is your tip or trick for us?
Yeah, so I mean, I'm a business school faculty right now. So I think in terms of differentiation and competitive advantage, what do you bring to the table that's different from the statistician? What do you bring to the table that's different from the data scientist, right? What do you bring to the table that's different than somebody with an MS in supply chain management or an MS in business analytics, right? And I think it goes back, and I'll go back to my first slide, to my abstract. And I really truly believe this, right? That I'm an IE by training, and I believe that industrial and systems engineers have this unique combination of the two things. You've got this mixture of quantitative analytical skills and training, right? You've taken OR courses, you've learned linear programming, you've learned statistics, you've learned simulation modeling, you've learned predictive analytics, you've learned data mining, whatever it is. But probably you've also learned some supply chain management along the way, right? And you might be working on your master's related to manufacturing technology, or you might be doing something in healthcare. Whatever it is, you are working in an application, right? Industrial and systems engineers, not all of them, but most of them, especially those who want to go into industry, they're not just doing the pure math. They're not doing just the pure OR. They've got an application, right? So that's what you need to do. You need to highlight that's what you bring to the table. You bring both. And these days, there's lots of shades to data analytics, data science, business analytics jobs, right? So if you're not a statistician or a computer scientist, you may not take a data science job. But a lot of the jobs are not data science. They are data analytics or business analytics, where you are really interacting with the people on the domain side and the computer programmers, or the people on the more database side of things. So there are all levels of different kinds of jobs these days, and you just need to identify what kinds are right for you, and then leverage this unique fix that you have. Sell yourself as somebody who can bring to the table the ability to talk to people on both sides. You can talk to the people who are doing the hardcore analysis, but you can also talk to the people who are going to be using the results. And in fact, your job is critical. You're going to translate, right? You're going to help the people who are going to use the results understand what the results are, understand how they can use them to make better decisions. And you can take your conversations with those people and turn around and talk to the people doing the analysis and say, that's not what we need. What we need is this. And so there's a lot of value to that kind of in between role, and it's a real need. That's what we see. I mean, that's when we designed our program for our MS program in analytics, that's really how we designed it, to fill those roles, because there are a lot of them.
Oh, thanks.
Mm-hmm.
Dr. Ryan, I have a question. I mean, suppose I graduated and I got a job in an industry, and down the line, after 5 to 6 years, how should I decide that should I go for an MBA or a PhD? That is the
so you're graduating with a master's degree in engineering. Yeah, I mean, I think you have to know whether you like research or not, right? So you wouldn't even consider the PhD unless you have a sense that research is something that you would want to do. Because even if you get your PhD and go into industry, you're still going to have to do the PhD, right? Which is research, right? So you're going to spend several years doing research. So my advice to answer that question would be to try to get some exposure to research while you're doing your master's degree. And I don't know exactly what the requirements are for your program, but I know that some masters are just coursework and others involve a thesis. But there's all kinds of in between as well, right? And so you can just talk to faculty, talk to them about the research. What do you do, right? And get an understanding of research that way. You could do, and if you're not doing a full thesis, you can still do a research project, right? And maybe get credit towards your degree for it. But you can't really know if the PhD is the right thing for you if you don't have that exposure to research, because that's fundamentally what the PhD is, right? Is doing the research. And it's the ability to focus in depth, very, very in depth on one small problem, right? And until you do it, you don't really understand it. But you can get some exposure to the concept of research.
Thank you so much.
Slightly modifying the same question, but this time it is for PhD students. If PhD students from engineering schools want to compete with PhD students from business schools when they are applying for job market, especially in this fall, we got so many opportunities. Even I think Nebraska has opened some couple of openings, right? I remember that. So what is your tip or strategies for industrial engineers, PhD in industrial engineering and operations research?
Yeah.
Because
so for
they might
academic
not
jobs?
have, in academic job, because they might not have publications ready. Probably they might be working, or they must have submitted. May or may not be to management science or operations research, but definitely like the journals which we talked about, EJOR, IJPR, IJPE, whatever, that kind of stuff. So what these people should look forward, and what immediate steps they should take?
Yeah, I think part of it is about targeting the right kind of university to work for, what kind of college of business to work for, what level. You're going to have a hard time if you don't have any publications getting into the top 10 business schools, right? So that's just not going to be feasible. You're going to be competing against people who have actual publications that have appeared, which is the challenge. But you might be, if you don't have an A at a Nebraska or somewhere else, you might be considered. You want to think about the expectations and be realistic in terms of the schools you're targeting. There's always the ability to move up, right? You go somewhere you do really well, you can always move and go upward. The other thing you want to do is you want to look at the programs, the educational programs that the college offers, and say, would I fit there? So, I talked about what we offer, and it's a good fit for somebody with an IE background. Yeah. So we have supply chain management, we have business analytics, we have all these courses that you guys could teach, right? So this is a great place for that. But not every college of business has that, and you have to be careful, right? There's some places where they really don't offer much other. They have their core course, basic intro, operations management. They might have some specialized courses here or there, but they don't have a major. Like we have a whole major in supply chain management, so we need all these courses. We have this minor, and we might someday do a major in business analytics, so we have all these courses. So you want to before you invest your time in really applying there, understand, are you a good fit, right? And that's really a lot of that is about who their faculty are, but also what programs they offer, what courses they offer. Could you see yourself? Usually they publish the list of courses, right? This is on my webpage. Our MS courses are on the webpage. Have a look. Are these things I could teach, right? Do they have a need for people like me, is what you want to ask yourself. And if they have a need for people like you, then you're going to be more competitive in it. And yeah.
Okay. Because when we join a B school, for instance, definitely there are opportunities to collaborate with the other, top professors in the same department.
Mm-hmm.
Not only in the B school, even on the engineering side. Let's say if we consider Nebraska, there is an industrial engineering school as well as a B school. So opportunities evolve and we definitely can shine, but we all need that first springboard to enter that stuff, right? So that is a place we slightly get confused. Are we the right fit, or what expectations is coming from the B school? How should we prepare ourselves?
Right. Yeah, no, I mean, and that's very true, that you do need the opportunity. And that's why if you don't have the right publications, at least have a good working paper and make sure it's in great shape, right? If you're really proud of the work that you're doing and you think it could fit, make sure you reach out to them and say, I'm presenting at this conference, here's my session, show up, and there's no guarantee they will, but if you don't have something written to show them, at least they can see a presentation by you, right? But I think it's also about being realistic and understanding that you do have the opportunity later on to move, that you don't have to go to the number 1 place right away, right? You can go to the number 30 place and then the 20 place and then the 10th place, right? So, and being in an environment where they reward certain things makes you work towards that, right? If you're in an environment where they reward high quality publications, that's where you're going to focus your effort. And if you're successful at that, then you can move up.
True, very true. Again, you said for a tenure track faculty, the person is supposed to even teach maybe 3 courses per semester.
No,
so
per year.
Oh, per year, sorry.
Yeah.
Oh, per year. That's a great relief.
Yeah,
now, even if it is 3 courses per year, is that the same course which is already there in the department, or the person should bring some new course to the department? How generally B schools look for that kind of teaching load?
Yeah, so that's a good question. And it depends a little bit on the size of the program. If it's a larger program, then they will typically try to give their assistant professors 3 sections of the same course, right? So you teach the same thing over and over. And typically they try to make it something that's pretty easy, right? They want to help you. They want you to have the easiest teaching load you can, right? So if they can do that, they will. Our program is smaller, right? So I have some faculty who are teaching all the same course, but most of my faculty do 2 sections of one course and 1 section of another course. But what I am able to do, I can't give them, we call it a prep, right? I can't give them 1 prep, they have 2, meaning they teach 2 different courses each year. But what I can do is keep it stable from year to year. So they might go 5 years where they just do these 2 courses and nothing else. So yeah, usually they're going to put a new faculty member into a course that already exists, not a new course. and they're going to try to give them as many different courses, as few different courses to teach as possible. Once you get to be a more senior assistant, they might move you around a little bit, because at promotion and tenure, some people do like to see a little bit more diversity in teaching and to be able to evaluate whether you can teach different courses. You might get the opportunity to develop a course in related to your research, but that would come later when you're more of a senior assistant.
Oh, thanks.
Mhm.
I think there is a question on the chat window. Ajit, would you like me to discuss that?
Okay.
Can the MS Industrial Engineering get into consulting roles? If yes, what kind of field of consulting would be the best fit? Shashank
I
is
used
asking.
to have a slide that I would show. So when I was teaching MBAs, I used to have this slide that I would show my first day of the semester, because MBAs, this is changing, but they used to not want to take operations and supply chain management. They used to not be interested. They wanted to take finance, right? But so I used to have this slide that showed consulting, and it showed the breakdown of, I don't know if it was measured in dollars or projects, but something like that, of so a measure of the amount of work consulting firms do according to areas. And by far the number one was operational consulting. Right now, I don't have that updated. So this was maybe 10 years ago or whatever. But operations consulting is a huge area. IT consulting is a huge area. So much more than, you don't see that much HR consulting. I mean, there is HR consulting, right? But I think really for somebody coming out of IE, you want to target that. You want to target, operations consulting, IT consulting in the sense of things like enterprise systems, right? Helping firms implement information systems that are going to improve their manufacturing processes or their transportation scheduling or whatever it is. And then the other thing is, of course, the quantitative skills. New consultants are often going to do a lot of data analysis, like it or not. Go to the strategic level. You're not doing the, corporate strategy consulting in your first job, right? You're going to do the data analysis that underlies the recommendations. So yeah, I think that's why IEs, they're really well positioned for consulting jobs, because if you've got the operational coursework, consulting firms love to hire people who work for years in a particular industry, right? Then they bring them in and they rent them out to consult for companies in that industry. So getting the work experience is really valuable. If you want to do consulting, healthcare consulting, working in healthcare before you go out and operate as a healthcare consultant. If you want to do consulting in, to large manufacturers, getting some manufacturing experience. They really like to hire people who've already got expertise in a particular industry. So yeah, so you're the best for an IE, I would say, operational consulting, information technology consulting, analytics sort of type positions. And luckily there are a lot of those. And you're obviously not going to go out and do the tax consulting, right? So
of course. No, after my master's, I was in consulting. I was with the Ernst & Young. I was in supply chain consulting. So I know what exactly you're talking about.
Yeah.
So I was in network design, vehicle routing, inventory optimization kind of projects I was involved in. Yeah. But equivalently in NC State, we have a good rapport with the Ernst & Young, Deloitte, these kind of consulting companies. Yeah. They heavily recruit industrial engineering for technology consulting.
Yeah, exactly.
Any other questions? Last chance for those who are already on the line.
Well, I hope this was helpful. I enjoyed talking to all of you.
Great. On behalf of Inform Sense CSE, I would like to thank Dr. Ryan for this wonderful session. You very well explained the differences between the business and engineering school on the basis of services, teaching, salaries, etc. And you gave good guidance to us master students and our interviews are coming up. We are applying for jobs, so that's great, very helpful. Would love to attend more sessions from you. I thank all the participants for joining us and making this event successful. Informs NCSU has more events lined up for the semester, so please look out for emails and social media updates. Thank you so much.
Thank you.
Thanks, Dr. Ryan. Thanks for your time. We will stay in touch.
All right, I'm going to stop my share if I can figure out how. There we go.
Sure.
All right, thank you.
Take care. Take care. Bye-bye.